Hello friends, this is Daniel. Today we are going to do something very interesting but that also can be very profitable. We are going to set our own infrastructure that allows people to create and play guess the number games. This is for educational purposes only, but it can give you an idea for the future if you have any dapp idea. However, regulations are your responsibility. We are just providing information and education. So for this infrastructure, what we're going to have is that we're going to have a smart contract that allows people to create and play guess the number games. Whoever creates the game posts certain amount of tokens, and this depends on the network. And then whoever plays the game has also to commit or to pay, better said, certain amount of tokens for play. If the player gets the number correctly, then the funds in the game are going to go to the player. But if we have 10 attempts and no one has guessed the number correctly, then the game will expire and the funds are going to go back to whoever committed the initial amount of tokens for creating the game. Also, and this is the part that might get interesting, whoever created the infrastructure is going to charge certain amount, in this case 1%, of all the funds that move outside of the contract. That means game expire, payment to the owner of the game, there is a commission for whoever created the smart contract. Game was solved, payment to the player, there is a commission to whoever created the smart contract. This is going to be working with BNB because we are playing in the Binance Smart Chain Network. We are going to do this in two steps. First, we are going to set our network, and then we are going to analyze our smart contract and deploy it and play with it. Hope that you enjoy. Let's start. As a first step, we are going to set up our network. We set a very convenient script for you to work that will help you to install in your Brown environment the networks that Moralis supports. We have the same structure for all the networks. You have to have the command that is Brownie networks add, then the kind of network that you're adding, the name that you want to give to the network, the host, the name of the network, the chain ID, and the explorer. We already filled all the configuration values that you need, except for one, which is the host. And the host is something that you are going to get while you visit Moralis. And here in Moralis, you can go to Speedy Nodes, and you can choose here all the endpoints that you might want to configure in your file and get your own personal link for that purpose. Once you have done that and you have these lines configured correctly, you could just execute the bin bash file, though for that you have to change the permissions. When you have done it correctly, when you do brownie networks list, you are going to see that all of these networks were already added. I hope that this is useful for you. We are going now to check our smart contract. Now that we have configured our networks, we can proceed to analyze our smart contract. I will not do it line by line because that's a little bit tedious, but remember that all the code that is part of this project you can find in the GitHub repository in the description of the video. So as any smart contract, we start with a pragma line and a license identifier. We need to import this BRF consumer base contract, which is the base for any contract that implements random numbers from Chainlink. And to install this, you have to do brownie pm install and then copy this part up until here. When you have done it correctly and you have executed that command, if you do brownie pm list, you are going to see that package appearing like it is appearing for me here. So that's all for this. Then we have the requirements, which we already reviewed. Then the contract itself is very easy. We have defined some data. Data like this key hash and fee is configuration data that we need for Chainlink to generate a random number and will vary network by network. We have this constant roll in progress that is just to symbolize that the dice has not fallen in a specific request for randomness. And we set it to 1000 because we are keeping the range of the secret numbers within 1 to 100. So 1000 will be the undefined, will mean the secret number has not come back yet. We have these events of interest that we need to track, and having these events allow us to have listeners off-chain that can store data. We can do this very easily in Moralis, but that's a topic for another video. But here we're going to emit these events whenever each of these events of interest happens. One is the game being created. The other one is the dice being rolled. That's sending a request for randomness to Chainlink. The game being served, the game being solved, and the game being expired. We have this stroke over here, which symbolizes the game. Like if you are thinking in object-oriented programming terms, these are all the properties that a game will have. It will have an owner, a secret number, a game balance, a guest count, and a flag that will tell us whether the game is active or not. We are going to create an index of games, and the index will just have an ID, which is something that we will continuously increment, and we're going to map it to this type of structure. We have this mapping here that is mapping requests for randomness that we are sending to Chainlink with a specific game ID. For the functions, we have a constructor function that we are setting with some variables that are configuration variables that we need for requesting randomness from Chainlink, and these we are defining in our deployment scripts. That is something that we are going to look at later on. We have these functions. We have the logic of the game in these functions. The first one is creating a game, which is basically just initializing our game object and making sure that the creator is submitting the right number of tokens for creating a game. We have the roll dice, which is sending the request for randomness to Chainlink and submitting the fee. Then we have the fulfill randomness, which is a function that Chainlink will call, not someone outside of the contract itself, but Chainlink, that happens blockchain to blockchain. And this fulfill randomness function is going to return us the random number and place it in the specific game struct that we just created corresponding to its ID. And we are identifying this ID because we are mapping the request for randomness that we are sending to Chainlink with a specific game ID. Then we have the functions to play the game. And to play the game, basically two things might happen, right? Either you guess correctly. Whenever that happens, this if is going to kick in. When you guess incorrectly, but you don't have the 10 attempts, then what is going to happen is that the player is just losing the amount of tokens that he submitted for his right to play. And whenever you guess incorrectly, this if is going to kick in the case that we have at least the 10 attempts. We have these getter functions just to get values out of the contract. And part of these getter functions are some backdoor functions that we have created in order to allow us to play with the code and have some way to debug and troubleshoot. For deploying, we have created some deployment scripts that are going to come very handy for you at the moment of implementing this contract. For these configurations, we are going to include a text file that you are going to convert into a .m file with the following settings. One is your account, which is the account that you need to create, and I will teach you how to do that in a minute. And then you will have to set these variables accordingly. For creating your account, what you have to do is brownie accounts new. You set it up, and then when everything is said and done, if you have done it correctly, when you do brownie accounts list, you are going to see the account that you just added. To deploy in the Binance Smart Chain network, we are going to choose the BSC deployment scripts that we have here. So for deploying this one, we just go to do the following. We're going to do brownie run deploy BSC, and we choose the network BSC test Moralis. The script is asking for my account password, so let's do it. And we have 3 deployments in the BSC network, and the latest one is in this address that it's reporting to us right now. But I had a little deployment already made in this network where we have already some games created. So we're going to do the following. We're going to do brownie console network. And this one has to be written this way. And we are going to do the same. BSC test Moralis. We are going to go in. And right now we are going to do guess number 1, which is the one that already exists. And we're going to get game balance of game 1, which is the second game that I created under this contract. And that one has some funds. So we're going to try to get those funds, and we're going to do it in the following way. We are going to do a loading of our account first. So I will create an account object that is going to be the same as accounts. Load testing account. And I have my account object, so right now I can play. Let's do the following. We are going to do play game, and for playing, it's going to be the game ID 1. I will guess that the secret number is 85. Let's see, 43. I like it more than 85. And then I have to submit my from, and I have to submit my account object that I just created. And right now I need the value. And the value required for playing is 0.00001 10 to the 18. This is because of the number of decimals. So we have everything that we need to play. I close my parentheses and let's try to play. Got my transaction back, and let's see what happened. But for seeing what happened, since we don't have right now a way to check the events, we have to go to some scanner to see what happened. So we go to guess number 1, address. We get the address of this game. We go to that contract and we see what happened. This is the transaction that created that game like almost a week ago. Seconds ago, someone played. And let's see in internal transactions. Whenever a game expires or someone guessed correctly, there will be an internal transaction here. That is the transfer of the funds outside of the contract. This is the way that you can deploy the contract using this deployment script. I hope that you have enjoyed and that this is useful for you. That way you can use Python scripts to just do your deployments in a very easy way and play with this contract very easily. Smash that like, subscribe to the Moralis channel. This is Daniel. See you in the next video.